The space telescopes orbiting Earth tend to get a lot of attention. It seems like there's always some beautiful new Hubble photo or a couple of new exoplanets discovered by Kepler. But there are some amazingly advanced ground-based telescopes too, and some of their coolest discoveries have come from Alma, a telescope that's been observing the universe since 2011. Alma, or the Atacama Large Millimeter Submillimeter Array, is made of a set of 66 telescope dishes stretched out over the Shanantor Plateau, part of the Atacama Desert in Chile. The phrase millimeter submillimeter describes the chunk of the electromagnetic spectrum that Alma detects, wavelengths that range from about a millimeter to about 10 millimeters on the shorter wavelength end of the microwave spectrum. Its huge array of dishes gives Alma the highest sensitivity of any millimeter submillimeter telescope in the world, and since it's the best in its class, Alma is always being used to observe and re-observe stuff in space. And some of the telescope's most amazing finds have taught us about everything from new exoplanets to ancient star formation to giant glowing clouds of hydrogen. Like when astronomers use Alma to clear up the controversy around a star called Fomalhaut. In 2008, the Hubble Space Telescope discovered what looked like an exoplanet around Fomalhaut. It was the first discovery of its kind. All the exoplanets discovered before that had been found indirectly, through clues like changes in the star's light. But you could actually see this planet directly. It looked like a denser point of light in the enormous diffuse disk around the star. And even though astronomers were pretty sure they'd discovered a planet around Fomalhaut, they weren't totally sure. Because the visible material in the disk, which is mostly small dust particles, does two things. First, it scatters lots of visible light, so if you're observing it in the visible wavelength range, the dust is very bright. And second, the force from solar wind from Fomalhaut can be strong enough to move those dust particles around. So astronomers knew that the images of the disk taken in visible light didn't necessarily correspond to the actual underlying disk structure. So that planet Hubble found, it might not have been there at all. And that's where Alma came in. In 2012, astronomers decided to study the disk around Fomalhaut in millimeter submillimeter wavelengths, which would allow them to see past the haze into the deeper structure where more massive particles live. When they used Alma to observe the disk, they saw a very sharp and well-defined inner structure, which basically looked like a ring of larger particles. And based on computer models of the ring, they found that it's probably shaped by a couple of shepherd planets, which orbit on the inside and outside of the ring and sort of corral the particles. Which means that thanks to Alma, we now have a lot more evidence that there really is a planet around Fomalhaut, maybe more than one planet. So Alma can see deep into a star's disk, but it can also see deep into the ancient universe. As the universe expands and sources of light move away from us, the light we see essentially gets stretched out so it has a longer wavelength in what's called redshift. If visible light gets stretched enough, it isn't visible anymore because it's gone past red and into the infrared or even microwave range. This means that really old distant things are invisible to our eyes and to telescopes that can't detect long enough wavelengths. But we can detect those things if we tune into a lower energy part of the spectrum, like say the millimeter submillimeter range. So Alma can see really ancient light. Astronomers have been using Alma in an ongoing project to re-observe Hubble's famous ultra-deep field image. The ultra-deep field shows a ton of galaxies in a tiny section of the sky, the size of a grain of sand held at arm's length. I mean literally tons. There are about 10,000 galaxies in the image. But we know that there's even more in that section of the sky, so astronomers are using Alma to see what Hubble couldn't. And last year they found that ancient galaxies in that section of the sky, like 10 billion years old kind of ancient, had high concentrations of carbon monoxide, which is associated with star formation. They already knew that around the same time there was a huge peak in star formation in the universe, but they weren't sure what caused all that star formation until they used Alma to observe those early galaxies and found the abundance of carbon monoxide. And now we know that the gas must have provided the right conditions for the stellar baby boom. Alma has also helped us learn why some of the largest objects in the universe are glowing. Specifically, these ridiculously ancient, huge structures called Lyman alpha blobs. They're called that because they have a very well-defined Lyman alpha spectral line, a specific wavelength of ultraviolet light that's emitted by hot hydrogen gas. So we knew that there were these huge, luminous clouds of hydrogen just floating around in space, but we had no idea why they were glowing until Alma. Astronomers using Alma found galaxy clusters inside the Lyman alpha blobs. And it turns out that these galaxies are forming stars at an incredibly high rate and emitting lots of Lyman alpha radiation because of all the hydrogen in those stars. The radiation then scatters off of the surrounding gas cloud and we see an enormous blob. So now, thanks to Alma, we know why Lyman alpha blobs glow, because of all the galaxies making stars inside of them. So even though Alma's only been around for a few years, it's already taught astronomers a ton about the universe. And with the constant flurry of papers being published with discoveries made using Alma, we're always learning more. Thanks for watching this episode of SciShow Space, and thanks especially to our patrons on Patreon who make this show possible. If you want to help us keep making episodes like this, you can go to patreon.com/scishow. And don't forget to go to youtube.com/scishowspace and subscribe.